In the previous lecture, we studied for the Zeeman effect and Zeeman Hamiltonian. Zeeman Hamiltonian is write down mu b over h bar and Lg plus 2Sg. Here, gyromagnetic ratio of orbital angular momentum is 1, and spin angular momentum, gyromagnetic ratio of spin angular momentum is 2. Here, we study for the J-core. We study for the J-core 3-half case, and in this case, and there are 4x4 matrix, and so Zeeman energy splitting has 4 energy levels, and in other case, in the J-core 1/2 subspace case, and so there are 2 subspace. Then from now on, and we will going on the first order perturbation of the Zeeman energy in the perturbative case. And prior to proceeding our calculation, and let me introduce the another theorem to calculate the matrix elements, and there are projection theorem. Projection theorem came from the Wegener-Eckhart theorem. Wegener-Eckhart theorem, but I do not prove these 2 theorems, but I will write down the result of this theorem. And here is any kind of vector Vg and matrix elements for Vg and J prime, and it can be write down as the J mj and v dot j. V means that any kind of vector, and j mj and over h bar square, and j plus 1 and j mj jg j mj prime. It is a projection theorem, but not without proof. And without proof, and I will use this theorem, and basically this V means that any kind of vector, and also, and Vg is the G component of a vector. Then the matrix element in the basis of the total angular momentum and the corresponding magnetic quantum number, and this can be write down as the matrix elements in the JMG, and it means that the the basis is same. Same basis means that it is diagonalized. Diagonalized matrix elements, because and the basis is same. It is the basis is different, and also and divide by the h bar square j plus 1, and also and here is a jg. And when we anyway, then you do not need to remember this formula, but I will use this formula, but I do not prove this projection theorem. Anyway, and let's use this projection theorem. We'd like to calculate the energy, perturbation energy, and we need to, for example, Hg prime expectation, and on the basis of the basis quantum numbers. Then it means that we need to calculate the UBB over h bar, and also and the expectation Lg plus 2 expectation Sg, and to make this kind of expectation of this Lg and Sg, and we will use this here V means that the LG and SG, and so these matrix elements can be write down as the projection theorem. So, and how to calculate this, and also here we should calculate that L dot J or the S dot J. So in the case, it means that they should have the spin-off coupling, and the total angular momentum is the L plus S. So it means that S means that J minus L. So when we scale in both sides, and S square means that J square plus L square minus 2 J dot L. So J dot L is coming from the this multiplication of the S square. So, and the J dot L can be inserted in this in here. So LG can be calculated like this. Similarly, in L also J minus S. So L square can be write down J square plus S square minus 2 J dot S. So from this, in the J dot L is that 1/2, and the J square plus L square minus S square. And in here, J dot S is that 1/2 J square plus S square minus L square. So now we can calculate the matrix elements J, M, J, and L dot J to calculate this, and we need to calculate this term. So L dot J and J, M, J. Then here, and from this, L dot J is coming from here, and the J square, L square, S square. So, and the factor is that the H bar square of 2, and the first one, and J plus 1, and plus L plus 1, and minus S plus 1. Likewise, in the J, M, J, and S dot J, M, J, it is a diagonalized matrix element. So H bar square over 2, and the J plus 1 plus S plus 1 minus L plus 1. So from this projection equation, and we can know that SG or the LG, then this can be write down here from this projection theorem. Then the J, MJ, and SG, and the J, MJ prime can be write down. The denominator is that the H bar square J plus 1, and also in the numerator is that the J, MJ, S dot J, and J, MJ, and J, MJ, and JG, J, MJ prime from the projection theorem. Then it can be write down because this term is coming from this, and the H bar square can cancel with each other, so it can be write down as 2J plus 1, and numerator J plus 1 plus S plus 1 minus L plus 1, and the J, MJ, JG, J, MJ prime. So, and now we can obtain this result. But the Riemann Hamiltonian also to calculate the LG expectation of the LG. So And similarly, JMJ and LG JMJ prime can be written down as 2J J plus 1, and also here L dot J expectation is here, coming from here, and the J plus 1 plus L plus 1 minus S plus 1, and JMJ and JMJ prime. So, and now we can calculate the first order perturbation of Zeeman energy. Is that Zeeman energy first order is that expectation of the Hamiltonian of the Zeeman Hamiltonian. Then the basis is the N L S J M J N H prime N L S J M J M J. It is the expectation of the Hamiltonian. Then, because the Zeeman Hamiltonian is that mu v b over h bar and N L S J M J. I'm sorry. And GL LG plus G electron SG and NLSJ MJ. So in this one is that UVB over H bar in GL NLSJMJ and LG NLSJMJ plus GE NLSMJ and SG and LSJMJ. So we already calculated the matrix elements of the LG and SG here. So we substitute here UVB over H bar GL LG is that J plus 1 plus L plus 1 minus S plus 1 over 2J plus 1. Basis is the same because basis is that the JG, this one and this one is identical, so we can extract in outside plus GE. In the spin SG case is that J plus 1 plus S plus 1 minus L plus 1 over 2J plus 1, and also basis is that NLSJ MJ JG and NLSJ MJ. So then we already know this. And it is the eigenvalue is the MJ H bar. So here H bar cancel with each other. So and mu BB MJ and GL J plus 1 plus L plus 1 minus S plus 1 over 2J plus 1 plus GE J plus 1 plus S plus 1 minus L plus 1 over 2J plus 1. So finally, and let's define the new gyromagnetic ratio. Then let's write down as simply and GJ and the mu BMJ here, and here we define that new gyromagnetic ratio, we call it as a lambda G factor. Then here GJ is that is kind of 1 over 2J plus 1, and GL J plus 1 minus L plus L plus 1 minus S plus 1 plus GE J plus 1 plus S plus 1 minus L plus 1. It is a new gyromagnetic ratio. So we already know that GL equal to 1 and the GE equal to 2. So it can be write down as that 2J plus 1. Here J plus 1 is 1, 2, so it is 3 J plus 1, and L case is it is 1 and minus 2, so it is minus L plus 1, and also S 1 and plus 2 minus 1 plus 2, so it is a plus S plus 1. So from here it is 1 plus J plus 1 plus S plus 1 minus L plus 1 over 2J plus 1, and it is a new gyromagnetic ratio. And also, and here it is widely used in especially in magnetism, so we should remember this new gyromagnetic ratio.